first, let's find what happens when the object is placed at F. Since the mirror is at 50 and the focal length is 10.17, then the object would be at 60.17. Is going to be about curved mirrors, but first I think we have to know what curved mirrors are.
Curved mirrors are mirrors in which the reflecting surface is bulged inwards or outwards.
As you see, this mirror bulges outward, so this is called a convex mirror. A convex mirror, even when we change the object distance, the image from it is always the same. So this mirror is used in supermarkets and also in cars rear view.
And this one, it's the opposite of that, and the reflecting surface is bulged inwards. And we can get different types of images as the object distance varies. So this can be used as a shaving mirror because it can magnify.
Yes, you're right. They may change when the object distance changes. For example, when the object is between the center of between the focal point and the mirror, the image formed will be virtual, erect, and magnified. And another example is when the object is between the focal point and the center of curvature, the image formed will be inverted, magnified, and beyond C.
So, in order to see this practically, we need to find the focal length.
Yes, and we have the formula we use for finding the focal length is 1 over f is equal to 1 over s plus 1 over s prime. And in this case, f is the focal length, s is the object distance, and s prime is the image distance. So the first thing we have to do is find the focal length using the mirror formula, and after that we can make sure if what we learned theoretically is true. And we have to realize that all distances are measured from the mirror.
Okay, so let's start measuring. Here we have a very crisp image of the candle.
Yes.
So let's measure the distance of the image and the object.
Okay.
From the okay.
The mirror is at 43.5.
Okay.
And the candle is at 56.
Okay. So when we subtract this, we get an object distance of 12.5.
Okay.
So S is 12.5. Okay, and the S prime is?
S prime is the mirror is at 43.5 and the image is at 97.
So again, when we subtract this, we get 53.5. By using the lens formula, we can obtain a result of 10.13. This is the focal length of the mirror. To be sure, we need to take another measurement. And here we have found another position of the image, the lens, and the object to get a clear image. And these are the position of the mirror is at 50 centimeter, and the position of the candle is at 63.5 centimeter. So we can get the position of the distance of the image. No, the object is at 13.5 centimeters is the distance of the image, and the distance of that was wrong. That's the distance of the object. The distance of the image is the distance from the mirror to the screen, which is 50. Then 92 minus 50.
42.
Yes. So 1 over 42. By using the mirror formula, we can get the focal length. I have calculated it and obtained a result of 10.21 centimeters. So we have obtained two different results, and we need to get the average of both. We need to add and divide it by 2. Then we get a result of 10.17 centimeters. So from this we can conclude that the focal length of the mirror is 10.17 centimeters. Now we can continue to the next experiment.
Now that we found the focal length, we can find the other image and object distances. First, let's find what happens when the object is placed at F. Since the mirror is at 50 and the focal length is 10.17, then the object would be at 60.17. There's no picture, there's no image formed. Yes.
And that proves what our textbook has already explained.
Yes.
It's because the image that's formed at infinity. Now let's see what happens if the image is at C, or the center of curvature, which is twice the focal length.
Okay. In this case, it would be 20.24.
34. So by adding 20.34 to the position of the mirror, we can get the distance of the object. That would be around 70.34.
The image is going to be formed at that point. So I think we'd have to move the screen.
Okay. Yes, you're right. Can you see the image?
Can you? Yes. Yes, it's diminished.
This should be diminished. It should be the same size.
Well, we cannot put the image exactly at C.
We cannot find the image beyond C, so we have to find the image at C. Let's try this. There is no image here, so it must have shifted. Let's try this. The image over there. So the image formed is at C, and it's inverted.
Now that we found the image at C, so where do we find the image formed when the object is between C and F?
So that would be around what centimeter?
Well, the C is 70.34 and F is, what was it?
60.17.
So it should be somewhere around.
Let's try 67.
67. Okay.
And where do we expect to get an image?
It would be beyond C.
So let us try and find the image.
Yes.
Can you see the image?
Yes.
And is it inverted?
It's inverted. Yes.
Is it enlarged or diminished?
It's diminished. Yes, it's diminished. And also beyond C, because the C position was 70.34, but the image position is beyond 70.34. So I think it's right. But this is not a crisp image. If it were a crisp image, it would have been magnified. So what if? What about now? Is it diminished or magnified? It's diminished.
Is it supposed to be diminished or magnified?
It's supposed to be magnified.
Why don't we try it again?
Yes. I think that image is magnified.
Somewhere around here?
That
Yes.
one.
Okay. It is still beyond C
Yes.
and magnified
Yes.
and crisped and inverted.
Okay.
Now, where else do we need to put the image, the object?
Between the mirror and the focal length.
Okay, so that would be between 60 and 50.
Yes.
Somewhere around 55. Well, we cannot get an image on the screen because, as we all know and expect, the image is going to be virtual. So there's no need for the screen. So let's take out the screen and see an image, and we can see an enlarged, erect, and magnified image in the mirror.
Yes.
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 No. So we've successfully proved everything that our textbook says about image formation, and I think this wraps up our experiment.
So that's it for today.
Yes.
Okay.